So hello everyone, my name is Shodakumar Singho and today I am going to discuss a very important topic, that is computation of area in surveying subjects. So let's start. So today we will discuss about the following topics like introduction, the hierarchical representation of various methods, that means what are the types of the estimation of area from the field notes, that means by using the field notes how we can determine the area from the plotted plan, the mid ordinate rule, average ordinate rule, trapezoidal rule and Simpson's rule, or you can say Simpson's 1/3 rule. These two I hope all of you already learned in the maths classes, in first year classes, so not an issue, I will repeat this. So let's start. So the term area in the context of surveying refers to the area of a tract of a land projected upon the horizontal plane and not to the actual area of the land surface. That means it is generally considered as a, it is actually considered as the actual area of a land surface, but here in surveying subject it refers to the area of a tract of land projected upon the horizontal plane. So area may be expressed in the following units. So square meter and square feet, these are the common, but yeah, hectares is also there as well as the acres. So we need to know about the hectares and the conversion value. So 1 hectare equals to 10,000 meters square, okay, and 1 acre equals to 43.560 square feet, okay. So these are the very important thing we need to know. So hierarchical representation of various methods. So area, yes, we can determine the area using the graphical methods as well as the instrumental method. Instrumental method means using the planimeter. There are types of planimeters are there, and by using those we can determine the area. But apart from that, how many types of graphical methods are there? So using the field notes we can determine the area as well as the from the plotted plan, and under plotted plan we have two parts, that means using the entire area and using the boundary area, and under the boundary area we will have some methods like mid ordinate rule, average ordinate rule, trapezoidal rule and Simpson's 1/3 rule. So I will come one by one on each of the types. So let's start. So first I will show you how to the computation of area from the field notes. So this is done on 2 steps, okay. Using this we have 2 steps. So in step 1 what we need to do is, the area of field can be directly calculated from the field notes. During the survey work the whole area is divided into some geometrical figures. So what are the geometrical figures? Like triangles, rectangles, squares, square and trapezium. Now for each of the cases we need to determine the area, right? So you know how to determine the area of a triangle. So if the dimension of the triangles are different, suppose this one is A, this one is B and this one is C, so what will be the area of the triangle? So the area of the triangle will be root over of S into S minus A, S minus B into S minus C, that we have learned in 10th level, right? And where S equals to A plus B plus C by 2. So this is the area, right? So in this way we can determine the area of the triangle where the sides are different value, and area of the rectangle you know how to determine, simply A into B, and for the square it is A square, right? And what will be the area for the trapezium? So to determine the area of a trapezium, that you already know, if this particular distance is A and if this one is B, and the height, if we consider, that is the distance between two parallel lines, if we consider small d, so the area will be half into d into a plus b. So this thing we already know, right? So this is the first step. So after dividing the whole area in some geometrical figure, so such as this kind of figure, and then the area is calculated is using these formulas. Okay, now step 2. So in step 2, if we consider that we need to determine the area, which is something like this. Okay, now this is the rectangular part. Now this portion can be calculated by using the simply a into b. Suppose this one is a and this one is b, so if you multiply this, you can determine the area. Now if you take the small portion over here, and if you consider this one as changing the color, and if you consider this one as x1 and up to this portion as x2, and you need to determine this particular area. So you know this distance, this horizontal distance, that means x2 minus x1, right? And this is the ordinate. Suppose this is O1 and this is O2. So you need to determine this area. So what will be the value of this particular area? That is simple. There is x2 minus x1. This is this distance, that is x2 minus x1 by 2, because you know the formula of the trapezium, right? So x2 minus x1 by 2 into the summation of the parallel two lines, that means the ordinates. So O1 plus O2. So in this way you can determine the area. Similarly, you can determine this portion also as well as this portion also. So if you make the summation of both these two areas, you will get the total area. So in this manner you can determine or you can compute the area from the field notes. Okay, so this is the concept, that how you can determine the area using the field notes. Now computation of area from the plotted plan. So from the plotted plan we can determine the area by using several methods. Now if we consider the entire area, then we have these three classifications. That means we can determine the area by dividing the total area using into some triangles, and also by dividing the area into some squares, and by drawing some parallel lines. So if we consider the entire area, let me show you the first case. That means if you divide the area into some small triangles. So suppose if we have the area something like this, so what you need to do is you need to make some triangles. Now you have 1, 2, 3 and 4. These 4 triangles, you just measure the area of these triangles. You know the determination, how to determine the area of a triangle, that is half into base into the height. You just determine the area of individual parts, and you just make the summation of all those, and you will get the area of the total portion. Okay, now by dividing the area into squares, so suppose you have the area something like this, and what you need to do is you need to make some squares on a tracing paper. Now what you need to do is you just make squares of equal size on a piece of tracing paper. So suppose we have a tracing paper something like this. Now we'll make some squares according to scale, that might be 1 centimeter square, 1 meter square, and you just, the tracing paper is placed over the plan and the number of full squares are counted. Okay, so suppose I am placing this paper over the plan, so the numbers of squares inside the area, that is counted, and the total area is then calculated by multiplying the number of squares by the unit area of each square. So in this way we can determine the area by dividing it into several squares. Now the third one, that is drawing the parallel lines and converting them into rectangles. So same case is over here. Suppose we have to determine the area of this particular portion. So what we need to do is, a series of equidistant parallel lines are drawn on a tracing paper. So likewise we have done over here, we make some square. Here in the tracing paper we need to make some parallel lines on equal distances. Okay. Now same thing we need to do over here, we need to place it over the area. Okay, and then the tracing paper is placed over the plan in such a way that the area is enclosed between the two parallel lines at the top and bottom. So suppose I am placing this over here, so thus the area is divided into number of strips. So here you can see these are the numbers of strips and they are replaced by perpendicular lines. So these are the strips and the distance is equal for each of the strips. Okay. So what we need to do is, we need to make some rectangles depending on the shape of the area. Okay. So after we determine the rectangles, so we can determine the length of each rectangles. So that means the first case, this is the length, for the second case this is the length, and for the third case this one is the length, right? So the final area, can be calculated by summation of lengths of the rectangles into the constant distance. That means these distances, these are the equal distances. You can write like constant distances. So in this way we can determine the area by drawing the parallel lines and converting them into rectangles. Now if we consider the boundary area, that means if we have the shape something like this, and we will make a rectangle which is completely inside, and then we will determine the area which is inside portion totally, and then we will determine the extra portion for each side by using some methods. In this method, a large square or rectangle is formed within the area in the plan, and then ordinates are drawn at regular intervals from the side of the square to the curved boundary. the middle area, here you can see the middle area is calculated in the usual way, and the boundary area is calculated according to the one of the following rules. So, these are the rule and these are the boundaries. So, these are the boundary area are calculated using the following rules. So, we will determine one by one how to use these particular rules and what is the formula, and then we will solve some problems. Okay. So, let us start. So, the first one is the mid ordinate rule. So, mid, that means it is a middle of ordinate. So, what is ordinate? So, if we have a chainage something like this, and if we measure a perpendicular distance, that means perpendicular offset, that is O1, or you can say it is a ordinate. Then suppose at chainage this point the ordinate value is O2. Then suppose at this particular distance the ordinate is O3. Similarly, over here consider this one as O4. Okay. Now, these distance are common distance which should be same. So, consider this distance as small d, that means the common distances. So, O1, O2, O3, they are the ordinates at equal interval. Now, if we consider the total length small l, so L is the total length of baseline, you can say. Now, what other things we need to specify? That is the small d. Small d is the common distance between the ordinates. So, this is the common distance between the ordinates. Okay. So, let us determine the area of this portion. So, as per the mid ordinate rule, here we need to determine the value of the mid ordinate. So, for this particular case, if you consider this as a trapezium, for this particular case, this is the mid ordinate. Suppose consider this is H1. This is the mid ordinate for the second zone. That means, if you consider this particular area, this is H2 and this is the H3. So, H1 equals to O1 plus O2 by 2. Okay, this is the average height. Similarly, H2 is equal to O2 plus O3 by 2, and H3 equals to O3 plus O4 by 2. Okay. So, in this way we can determine the value of the mid ordinates. Okay. Now, the area, if you determine already the value of the mid ordinates, the area will be nothing but, for the first case it is H1 into D. Okay. For the second zone, this one plus H2 into D, and for the third one it is H3 into D. So, you just take the common, that means D, and it will be H1 plus H2 plus H3. So, ultimately we got that it is common distance into sum of the mid ordinates. It is common distance into sum of the mid ordinates. So, I hope you understand the mid ordinate rule, and definitely we will solve a problem to clear this. So, So here it is given the following offsets were taken from a chain line to an irregular boundary line at an interval of 10 meter, and these are the offsets. Okay. Now compute the area between the chain line, the irregular boundary line, and the end offsets by the mid ordinate rule. So let's try to draw the diagram first. So the first reading is 0, that means for this case it is 0, and the interval for each cases it is 10 meter. Okay. So here it should be 2.50, not point, it is placed wrong, it is 2.50. okay. So this is not. Now as the interval is 10 meter, so after 10 meter the value is 2.50. so consider this one is, this height is 2.50. okay. Then another 10 meter, consider this one 3.50, so something over here. Now another 10 meter, it is 5.0. I am trying to make it in a scale. Now another 10 meter 4.60, so this is the 10 meter distance, and it is over something like this. And after that this is 3.20, so it is something like this, and the last one is 0, that means it will connect with this place. Okay. So I will just join all these points. Okay. So these are the all the distance is 10 meter, right, and the ordinate value is given. So this is O1, at this point it is 0, this is O2, this is O3, this is O4, this is O5, this is O6, and this is O7. So now we need to determine the mid ordinates. So these are the mid ordinates, right. So consider this one as H1, this one as H2, this one as H3, this one as H4, this one as H5, and this one as H6. So we need to determine the value of the H1. So what will be the value of H1? That will be 0 plus 2.50 by 2. H2 will be 2.50 plus 3.50 by 2. H3 will be, this is O1, O2, O3, so 3.50 plus 5.00 by 2. H4 will be, this one is H4, so this distance plus this distance by 2, so 5.00 plus 4.60 by 2, and H5 similarly it will be this plus this, that means O5 plus O6 by 2, so that means 4.60 plus 3.20 by 2, and last one, that is H6 is equal to 3.20 plus 0 by 2. So these are the value of the mid ordinates. Now what you need to do is just determine the area. So area will be nothing but the common distance plus, sorry, into the summation of the mid ordinates, right. So D into H1 plus H2 plus H3 up to H6. So ultimately if you solve this, the result you will get, that is 188 meters square, because the value of D is 10, and after adding all these value you will get 18.80. So ultimately the answer will be 188 meters square. Okay. So in this way you can apply the mid ordinate rule and it will be the answer. So, thank you.